Hello everybody. In this video we will talk about the history of the periodic table and the story that how we can have the periodic table that we have today. Scientists have been working on putting this periodic table together since 1780. So what we see now never existed, although elements did exist, but nobody knew that they could ever be arranged in a table. So there were many different scientists who played a very important role in putting this table together that I will talk about in this video. But the one scientist who is known as the father of the periodic table is Dmitry Mendeleev. He was the first one who actually gave us a table format. Scientists did work on it before then, but they were giving us ideas how elements could be put together in different sets based on their properties. But Mendeleev was the first ever scientist who gave us a periodic table in the form of a chart, you can say, where you can see all the elements in one form. So first, you need to know what is periodic table. It's a table of elements, and a lot of information that we get from the periodic table. We cannot even do chemistry without periodic table. And it also helps scientists, after Mendeleev's work, it helped scientists to discover the elements that were not known at that time. Because when we had the elements arranged in the table form, we were able to predict that there is, empty space here. That means there is an element that we don't know. So Mendeleev is known as father of the periodic table. But let's talk about who was before then. Um, so the development of the periodic table brought a system of order to what is otherwise a collection of information, basically. So having a periodic table that we have today is a milestone, and it enables scientists to do many things that they were unable to do otherwise. So the very first scientist who ever attempted or even thought of putting the elements together was his name was Dobrinier. In your book, this information that I'm talking about is on page number 68 and 69. So I will suggest that you go to page number 68 and through 69, read it, and you will see a little bit of further details in reference to these scientists. So anyway, Dobrinier was the scientist who first ever started putting elements together in the form of three sets. So he will take any three elements, and he will he said that these three elements behave the same. So he gave us an idea of having triads. Okay, like he said that we can have barium, strontium, and calcium together. And the way he said it was that the elements in the middle of the three sets is the properties of this element is the average of the properties of the other two elements. So he arranged the known elements at that time, and keep it in mind that we did not know all of the elements that we know today at that time. So whatever he knew at that time, he started putting them together in the set of three, based on the concept that the middle element has the properties, atomic mass, density, has the properties that is an average of the properties of the other two elements. So we call it set of triads, so Dobrinier triads, and it's happened in 1827. And this is how it looked like. The other scientist that came after the Dobrinier was Newland. Newland worked on the same lines of Dobrinier. At that time, we knew about 62 elements, and this is the time of 1863. And he said instead of three, let's have 8 elements together. So he said that if I put 8 based on the properties, I can have set of 8s who have similar properties. So he started arranging elements based on the set of 8. Okay, and we call it law of octaves. Okay, law of octaves. Octa means 8. So he observed that when he put the 8 elements together, they have similar atomic mass, similar physical chemical properties. So he started arranging the elements based on the atomic mass a little bit. All right. So we have Dobrinier, then we have Newland, and after the Newland, Mendeleev that I mentioned before got the credit of actually publishing the first ever periodic table. So he looked at the work of Dobrinier, and he looked at the work of Newland, and he said, okay, instead of having 3 and the set of 8s, let's arrange the periodic table by atomic mass. So he arranged the periodic table by atomic mass, and he gave us a proper periodic table format that we look at today. So you know the modern periodic table. That is why he's called father of the periodic table, because he was the first one who published it. And after we had a published periodic table, there were some spaces here or there that were not filled, and that helped scientists a lot to discover the elements that were not known at that time. So here is the little bit of Mendeleev's periodic table that he organized in the form of a table. He was working in the set of 8s, and then the first one he ever published it looked like this. So do you see that if you look at the periodic table, you have lithium, beryllium, boron. It's going in the periods. So he placed the elements that have similar properties by periods in the rows. So if you look at the periodic table, I suggest you have a periodic table in front of you. So if you pull out the periodic table, you will see that the elements are arranged by the properties in the rows, in the periods. And then you will also see that there are spaces that are blank. And when these spaces are blank, that means these elements were not known at that time. So this is Dmitry Mendeleev's 1872 periodic table. So you see here that the spaces marked with blank lines represents element that he expected that he deduced that they exist, but they were not known at that time. And he gave us a symbol of those elements, that this is how it should be. But we didn't know those at that time. So Mendeleev really, it was a milestone by that time that he did in the formation of a periodic table. The next scientist, you see here, again, same concept. The next scientist who changed the periodic table, brought it from Mendeleev to this modern periodic table, his name was Moseley. So Moseley took the same periodic table that was put together by Dmitry Mendeleev, and he rearranged it. He rearranged it by atomic number. And he said that if we rearrange the periodic table instead of atomic mass by atomic number, elements repeat their properties. Okay, so that process of repeating properties is called periodicity. Okay, periodicity means that every few elements will repeat their properties. So the periodic table that we know today is actually given us by Henry Moseley. That is the modern periodic table, which is arranged by atomic number. So he said that when elements are arranged in order of increasing atomic number, their properties recur periodically, and that is called periodic law. So you should also be familiar with the term periodic law. Periodic law is again that when elements are arranged in order of increasing atomic number, their properties recur periodically, and that is the periodic law. So make sure, again, as I said, it is in the book, page number 69 and 68. You need to look at these scientists, and maybe you can read it in detail. But you need to know the name of the scientist. You need to know that there was a set of triads, then octaves, and then Mendeleev came in, whoever printed the first periodic table arranged by the mass, and then Henry Moseley was the one who arranged it by the atomic number. So the periodic table that we have today has different families and different kind of arrangements. But before we go there was another scientist. His name was hold on one second. There was another scientist who pulled out the lanthanides and actinides. Glenn Seaborg. Glenn Seaborg, I mean, we can even have videos of that. Glenn Seaborg was a scientist who was the last one who worked on the periodic table in very recently, 1945. And these elements that you see here, they used to be part of the same body of the periodic table. So he was the one who separated them. So you will see some periodic tables that these two rows or these two periods are part of the same periodic table here, same body of the periodic table. But then he separated them based on their properties. You know, these are highly radioactive elements, and he pulled them out of the main body and have them here. So these are the lanthanides and actinide series. So these lanthanides still belong to period 6, and this one still belongs to period 7, but they are written at the bottom. So this is the latest form of the periodic table that we see now. So periodic table can also be arranged by the sub-levels. You know, we talked about it earlier on when I was talking about atomic structure, that we can talk about S block, P block, B block elements. There is another way of periodic table that these are the main group elements, you know, and these are called the rare earth elements at the bottom here. Rare earth elements, these are transition elements. So there are many different ways of naming or grouping the periodic table. So we have group, these are all A elements, you know, 1A, 2A, 3, 4, 5, 6, 7 A's, and then these are the B elements. So there are, I mean, as I said, there are many different ways of naming the periodic table or numbering the periodic table that we will discuss in a few minutes. Okay, so periodic table, the way it is arranged now, it is divided into metals, non-metals, metalloids. So here is the, you know, staircase kind of thing, a diagonal line, a stepped diagonal line that divides the periodic table. Everything below the line is metals, and everything above the line is non-metals. I'm sure you already know this information. So the elements that are sitting right above and below this line are metalloids. Metalloids means semi-metals. So everything, you know, they like silicon, germanium, osmium, antimony, tellurium, and astatine. These elements are metalloids, means they have the properties of between metals and non-metals. So keep it in mind that the periodic table is divided into two sections. Everything above the line is non-metals, and everything below the line is metals. So here are the three broad classes that represents the transition metals, representative metals. So when you look at the periodic table, you see that we have we call them main group elements. So group 1, group 2, and then this part here, you know, starting 13, 14, 15, 16, 17, and 18. As I said, they're also called A elements, you know. So we call them main group or representative elements. Main group elements. I didn't mean to erase it. Okay, so main group elements. And so we have 1A, 2A, 3, 4, 5, 6, 7, 8 A's. And those are the main group or representative elements. The elements in between that are called transition metals. Okay, they are B elements. So we have 3, 4, 5, 6, 7, 8, and 1B and 2B. And the elements that are at bottom that were pulled out by the Glenn Seaborg, you know, they used to be part of the main body. Now they're pulled out. They're called lanthanides and actinides, and they're also called rare earth elements. So you have to know these names, you have to know these terminologies, that we have main group elements, okay, we have transition metals, and we have lanthanides and actinides, and they're called rare earth elements. All right, so this classification of periodic table you have to memorize. All right. Additional grouping in the periodic table. You know, as I mentioned before, there is a diagonal staircase line. Okay, everything below the line is metals, everything above the line is non-metals, and the elements right above and below the line, this and this, 1, 2, 3, 4, 5, 6. These elements are called, including this, are metalloids. Metalloids mean semi-metals, means they have the properties of both metals and non-metals. You need to know the grouping: non-metals, metals, metalloids, and these are called noble gases. means noble gases or inert gases, because they don't react. So they're the same thing. I mean, I will give you the name of others too. And then here bottom are the rare earth elements. So this is another way of grouping the periodic table. As I said again, periodic table can also be divided by the uh, energy levels or sub-levels. So elements group 1 and 2, or 1A and 2A, they're called S block elements. Okay, S block means that their sub-level is partially filled. S sub-level is partially filled. So all of them, like if it is period 1, then this is 1s1, 2s1, 3s1, 4s1. This is all s1. Okay, 1s1, 2s1, 6s1. This is s2, 2s2, 3s2, 4s2. This one is in 1s2 right here. So these are S block elements. That means that S sub-level is partially filled. These are all called P block elements. That means their P sub-level is partially filled. So you will see P1, P2, P3, 4, 5, 6. So if I'm looking for this one, I will have the electronic configuration of 4s2, and then 4p4. It's in the period 4. So that's why it's 4p4, because it's in the period 4. This is 3p4 because it's p1, p2, p3, p4, but the 3 is coming from the period 3. So there is a period 3 of the periodic table, and that gives it the 3 here. So I can do the electronic configuration of the element without even knowing who the element is. And then here in between are the D block elements, and they go from D1 to D10. Okay, and then bottom here are the F block elements, the lanthanides and actinides. So if you do not understand this, please come see me, ask questions. But you have to know that these are S block elements, these are D block elements, and these are P block elements. That means that sub-level is partially filled for those elements. So from here on, we need to talk about the groups and families of the elements. So as you know, we have 18 groups. Okay, groups are also called families. Why are they called families? Because all the elements in one group have similar chemical properties. They have similar chemical properties. And why do they have similar chemical properties? Because they have same number of valence electrons. So all elements in one group or vertical column have similar chemical properties because they have same number of valence electrons. They have the same kind of electronic configuration. And then we will go with the names of those families. Just like we have our family names, these elements also have their family names. So the next will be in this separate video because the video is getting too long. So just take notes on this one. I have covered up to page number 71 of your book. So we will go from there as we move further on. All right, thank you everybody.